Hello everybody and welcome back. We're continuing on with the Csmc, that's the senior paper put out by the University of Waterloo. We're looking at the 2013 paper, the paper written in 2013, and we're all the way up to question number 3 in A part. And you might remember A part is the one where we just need the final answer, we don't need to justify our solution. So hopefully you've given this question a go and you're ready to see how at least I handle it. Other people might try different ways. But let's take a look at question number 3 together. So, question number 3. If 99 factorial, that's what that little symbol with the exclamation mark means, divided by 101 factorial minus 99 factorial is equal to 1 over n, determine the value of n. So here they explain, just in case you haven't seen this notation, and that's okay. Not everyone has seen all notations. If m is a positive integer, then m factorial represents the product of the integers from 1 to m, inclusive. So 5 factorial is 5 times 4 times 3 times 2 times 1. And we can work that out on a calculator. We get 120. 99 factorial would be 99, 98, 97, 96, all the way down to 4, 3, 2, 1. So multiplying all those together. It's a big number. Last I checked, I think my calculator only goes up to 70 factorial. Yours might be in a similar boat. But, yeah. So, 99 factorial, certainly a big number. It's not something we want to write down, is sort of the point. Okay? So, how are we going to approach this? Well, we got factorial, we got 99 factorial, and then 101 factorial minus 99 factorial. We have to get this in the form 1 over n. Okay, and I notice there's a 99 factorial here and a 99 factorial here. So maybe we could factor the bottom and cancel out some 99 factorials. And it turns out that's exactly what we're supposed to be doing. So we grab ourselves a scrap piece of paper. So n factorial, he's the product of the numbers from 1 up to n inclusive. So we have this nice little recurrence relation. He is n times n minus 1 factorial. Okay? Product of the numbers from 1 to n. Product of the numbers from 1 to n minus 1 multiplied by n. There's your little extra product. Okay? This relation is something, if you haven't seen it before, you might try and prove it just based on the definition that they gave us in the question. But most people who've seen factorials will know this relation, so we can move on. At some point I'll do a video on non-factorials, so we'll cover it more in depth there. But if I haven't put that up yet, or you just can't find it, try it for yourself, or you can look online. So 101 factorial, well that's 101 times 100 factorial. Right? That's just what we've noticed here. 101 times 100 times 99 times all the way down to 1 is the same as 101 times 100 times 99 times 98 all the way down to 1. We're just separating it out a little bit. Okay, well that's all well and good, but we're sort of trying to look for 99 factorials. Well, if we go one step further, we get times 99 factorial. So it's 101 factorial is 101 times 100 times 99 factorial. So 99 factorial over 101 factorial minus 99 factorial. Well, that's the same as 99 factorial over 101 times 100 times 99 factorial minus 99 factorial. So on the bottom, we can take out a common factor of 99 factorial. We're left with 101 times 100 minus 1. And we still keep our 99 factorial on the top. Well, we have something on the top and the bottom. They can cancel each other out. And then, wouldn't you know it, we're left with a 1 on top, which is what we're looking for. And we can simplify the bottom a little bit. That becomes 10099. So n equals 10,099. So, quick little question. I admit if you are just seeing factorials, it might have taken you a while to approach this question and then figure out this relation. But once you have this relation and you realize, you know, the 99 factorial on the top, he's got to go. So there's got to be a way to cancel him out with something on the bottom. That's the real key. We know we've got a 99 factorial on the bottom as it is. We just need to turn this 101 factorial into something times 99 factorial so we can factor it out. And it all follows from there. If I hadn't seen factorial, I might have tried this, and I could very well have failed, and I would have moved on. And if you don't understand a question, the best thing is always to move on. If you have time at the end, come back to it and keep trying it. And as you're trying it, write down what you're trying, because that way you can still get part marks even if you don't understand it to the point of solving the question. But yeah, factorial is definitely something, if you want to take these contests seriously, factorial is definitely something that you should see by now. There's lots of little things you should see. Factorial is a good one. Just sort of basic angle stuff you should see for the geometry style questions. As you get into the written stuff, part B, techniques you might want to be familiar with would include something like induction, which is something that is not always covered in school. There's lots of little things, and I try and make my side videos specifically for these sort of problem-solving techniques. But they're really things you should be familiar with if you want to get a good score. That said, if you're just trying these things casually and for fun, then you may not get the factorial question. Then again, watching this video, you may have learned something, or you may have been spurred on to find some more factorial on your own. It's Factorial. You can look that up online or try and find a video of mine if I've made one by now. And you can learn a little bit more about factorials if you've never seen them before. But if you have, that was a very quick question as we just showed. So we're ready to go, we're feeling good. It's on to question number 4, and we'll tackle that in the next video.